Good day, students. Today I want to solve problem under logical reasoning that involve making use of truth table. What is truth table? Truth table is a table that evaluates the truth value of a statement. And we are going to start with implication. The statement is false if the antecedent, which is the first statement, is true, and the second statement, which is the consequent, is false. Okay? Otherwise, it is true. Now, what I'm trying to say is that this is the first statement, this is the second statement. We call the first statement antecedent, second statement as the consequent. And we are told that if the antecedent is true and the consequent is false, the statement is false, otherwise it is true. Now let's fill the truth table first. We have two statements, that is 2 squared, which is 4. We're having 4 rows. T, T, F, F. Now fluctuate it. T, F, make sure true come first, F, true false. See, the second statement is false here. We turn this true to false, otherwise it is true. Let's go to exclusive OR. The statement is false if both statements are true or false. Both statements we are saying is that if the antecedent and the consequent are both false or they are both true. Now let's fill the first one. True, true, false, false. True, false, true, false. If they are both true under exclusive OR, if they are both true, it is false. And if they are both false, it is false. Otherwise, it is true. Now let's go to bi-implication. Under bi-implication, the statement is true if both statements are true or false. That is, if both antecedents, which is the first statement, are true, with the consequent they are both true or they are both false. Okay, now let's see what I'm trying to say. Otherwise, it is false. Okay, now let's see. T, T, F, F. T, F, T, F. It's saying that under bi-implication, the statement is true if both statements, what statement I'm talking about is both antecedent and consequent, they are both true or they are both false. The statement is true. See, they are both true, is true, they are both false, the statement is true, otherwise it is false. Okay, you can just see that exclusive, where you have false false, you're having true true. When you're having true true, you're having false false in bi-implication. Now we want to use the truth table to solve the following. Now since we need conjunction and disjunction, let's get the truth table for the conjunction and disjunction so that it will help us. Now P conjunction Q, P conjunction Q and P disjunction Q. Let's see. P conjunction Q, when it's conjunction and, only true true that will give us true. True true will give us true, otherwise false. Under disjunction, only false false will give us false. False false will give us false, otherwise it is true. Okay, just understand this. Now let's now solve this problem. We are told that use the truth table to solve the following. When you negate P conjunction Q, it must be approximately equals to negation of P disjunction negation of Q. Let's draw the table. This is the A part. Let's write the question first. P Q let's do P conjunction Q. Before then, let's write it T T F F T F T F P conjunction Q. P conjunction Q will be T plus this conjunction will be T. Conjunction is AND. When you have T true and false, it will be false. False and true will be false. False and false will be false. Okay, because AND false affects true in AND. Okay, now let's negate this. Negation of P conjunction Q. Negation of P conjunction Q. Negate T. False negate false. True true true. Now let's get negation of P. Negation of P. Let's negate this P. You're having false false true true. Let's negate Q. Negate Q. When you negate this Q, you're having false true false true. Okay, now let's now find the disjunction of it. Negation of P disjunction negation of Q. Now we want to see, and this disjunction is OR. Don't forget it's OR. Let's see negation of P disjunction negation of Q. You have a false. FT, you pick T. I said TF, you pick T. True. You have to pick true when you're having mixture of F and T. TT, you're having T. You can see it. You now go back and check. Negation of P conjunction Q must be approximately equals to negation of P disjunction negation of Q. Let's check. F F T T T T T T. They are the same. Now let's go to the B part. Negation of P disjunction Q approximately equals to negation of P conjunction negation of Q. Okay, from here you're having P, you're having Q. Now you do what is inside the junction first, but before then let's write T T F F T F T F. Now let's do P disjunction Q, P disjunction Q, T T give us T, this O, T F give us T, F T give us T, F F give us F. Okay, now let's negate it. Negation of P disjunction Q, negation of this F F F T. Okay, we have finished with the left hand side. Let's go to the right hand side. Let's do negation of P. What's negation of P? That's F F T T. Let's do negation of Q. Negation of Q, F T F T. Okay, negation of P conjunction negation of Q. Now they are together, and this and F F is F, F T, this F will affect it, F T F F T T T. Okay, they must be equal. Let's check. Negation of P disjunction Q must be absolutely equal to negation of P conjunction negation of Q. Let's see, F F F F F F T T. This is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.